paper in front of you. What are we doing today? Lesson 6.2, properties of parallelograms. This is a preview of the entire lesson right here. Okay, this is everything that you need to really know for your lesson. And the rest of it is just applying some things. So, this first property here, by the way, I'm recording this. These are both already on YouTube. The last lesson is on YouTube as well. This first one here, okay, read that over. If a quadrilateral is a parallelogram, then its opposite sides are congruent. So you see this side AB and this side CD are opposite, right? So if they're opposite, that means they're congruent. So I'm just going to go ahead and write next to it, opposite sides are congruent. That means if this side is 4, then this side is 4. Does that make sense? And if this side is 7, then this side is 7. Does that make sense to you guys? Okay, the next one. If a quadrilateral is a parallelogram, then its opposite angles are congruent. Okay, so the next thing is opposite angles are congruent. Okay, well, what are the opposite angles like B and D, the blue ones, and A and C, the red ones? I just realized I should probably tell you guys what a parallelogram is. I know you guys have seen this before. What do I know about a parallelogram? The opposite sides are congruent, but they're also parallel. A parallelogram has 2 sets of parallel sides. You see that? So this set is parallel to this set, and this set is parallel to this set. Does that make sense to you guys? Okay, so we also know the opposite sides are congruent, and the opposite angles are congruent. The third thing we say is that its consecutive angles are supplementary. So B and C, the blue and the red pairs, each blue and red pair is supplementary. What does supplementary mean? They add up to 180. So the third one is consecutive. Do you guys understand what it means by consecutive? Like, give me numbers starting with 1, consecutive numbers. 1, 2, 3. So one after the other, right? So consecutive angles means like this one, then this one. Or this one, then this one. This one, then this one. Does that make sense?
Yes. Does that be alphabetical?
Usually it will be. But, so consecutive angles are supplementary. And that means they add up to 180. And then the third thing has to do with diagonals. So a diagonal, if you remember, a diagonal is the line that connects the vertex to the vertex. Remember we did that yesterday with concave and convex shapes. We showed diagonals. So the diagonal of a parallelogram is here, and there's another. You see there's 2 diagonals. You see that in red and blue, and you guys can look on your paper, same thing, right? These 2 diagonals. Well, what does it say? The diagonals bisect each other. What does it mean to bisect?
They split it evenly.
Yeah, split them evenly. Cut each other in half. So the fourth thing is diagonals cut each other in half. Or really, I like it better, diagonals split each other evenly. Okay. The real word there is bisect each other. But if bisect throws you off, it just splits each other evenly, right? Does that make sense? So we should get familiar with the term bisect. So diagonals bisect each other. In fact, that's what I'm going to write here. So diagonals bisect each other. Is the word that you really should have. Diagonals bisect each other. Okay, any questions on that? So these are the 4 concepts that we're going to be working with today, and they're pretty straightforward, I think. The question is, how are we going to actually use that in a type of question? So I'm going to just kind of march through the book here. we take a look at this example here. And I'm just going to copy it. And this kind of covers a lot of stuff for us. So the diagram shows the parallelogram-shaped linkage that joins the frame of a race car to one wheel of the car. So basically, you've got this parallelogram here. All right? In parallelogram PQRS, so PQRS, it says QR is 48 centimeters. So I'm going to put that up there. QR is 48. So that's 48. RT is 30. So from R to T, this from here to here is 30. I'll use yellow so you can see it. 30 from here to here. From here to here. You see that? RT. Here's R, here's T. So RT is 30. And the measure of angle QPS, that's here, not UPS, but QPS. Ha ha ha. QPS is 73 degrees. Okay, find each other measure. Okay, so if this angle is 73 degrees, what do I know about this angle? It's 73. Good. And then what do I know about, if this side is 48, what do I know about this side here?
48.
It's also 48. Does that make sense? And if this is 30 from here to here,
30 from PT.
then PT is also 30. Does that make sense? But that's not the only thing we know. We also know that these angles here, they're not equal to 73, but they are what? Begins with an S, supplementary. So if that's 73, then this is 180 minus 73, which is 107. Does that make sense? Question?
Can you make that picture bigger?
Yeah, let me see if I can do that. Does that make sense? It's kind of hard to see, I know. What do you call it? Yes, sir.
Who won't say 93?
Oh, just from him, you mean?
Oh, no,
Oh,
sorry.
see, that's brotherly love right there. I like it. All right, yes, Mr. Small?
So, wait, that top blue one says 93, right?
73. This is 73, that's 73. This is 107, that's 107. This is 30, and this is 30. That side is 48, and that side is 48. Does that make sense? Okay, so you guys should be able to do that just based on what we just learned. No, not the sides, the other angles. Yeah, because 107 plus 73 is 180. All right, does that make sense to you guys? Okay, so that's just one example of it. Another example would be something like this. So we see another parallelogram is like holding up this backboard here. So it says LM is 28. So here's 28 from here to here, L to M. And LKN, that's this angle right here, is 74 degrees. It says find each measure. Well, KN, if LM is 28, what's KN? 28, simple as that. What's NML? So NML is this angle right here, would be 74 degrees. And what's L? Oh, it says, it also says LN is 26. So the distance from L to N is 26. So it's asking the distance from L to O. Well, that would be 13. Does that make sense? You guys got that?
Yeah.
Okay. So these are the simplified examples, simple kind of examples of that type of deal. You guys ever see this picture of Mr. Rachel's? Dr. Rachel's? Dr. Rachel's. Dr. Rachel's. He's the head of school.
Why do you look like that?
Why did he look like that?
Oh, why did he?
Because he was cool. I don't know. I think it's pretty cool.
Man, I'm gonna miss you, Greg. Oh my god.
Marv, don't catch any more that you shouldn't have.
He said, why do you look like that?
Okay, let's keep going. Sorry, guys. Sorry for that. Now, this is more like the type of example that you're going to see. Algebraic.
Expression.
What? Algebraic. Hold on. This is basically it, guys. I'm telling you. I'm almost done with the lesson. So let's just rock through it.
Junior, are you playing the game Friday?
What game?
Church versus staff.
Yeah.
What's it
Oh.
called?
No, teachers versus staff.
Is it
Church.
at night?
Yeah,
Is it
night.
like
Yeah,
night?
it's like King Night or I don't know.
That sounds live.
Night?
Mr. Can you
You
ball
should
out
do
this
it.
time in here?
Now I'm champions.
With basketball?
Yeah.
I can play, but I would never actually be on a team that people were trying to win a game. You know what I mean?
You exactly like me.
Like if you were actually trying to win, I wouldn't recommend that you pick me. But I'll play a game, you know. I won't be shy. But if you're trying to win, I'll sit on the bench. I got no problem with that. I got no pride issues with that. All right. So this would be a type of question that you would be more likely to see on a test. Okay? So in this, I would ask you a series of things. For instance, I might ask you to solve for x. So, or I would probably ask you to find the side LM. So what is LM? What is that length? What is the length of LM?
Oh, you have to set them equal, right?
So I know that LM is equal to KJ, right, guys?
Yeah.
Those two are equal to each other.
What's the theorem called?
That's just one of the properties of parallelograms. Okay. No. So
You say no?
3x plus 14 equals 7x, right? And then all I have to do is solve for x, and then I can plug it back in to get the side. Does that make sense? So I know they're equal, so I set them equal. Questions? Subtract 3x, I get 14 equals 4x, and then I divide by 4. And I would get x equals 14 divided by 4, which is 3.5. Cool? And then if I want to get that side length, well, I can just plug it back in here because I know they're both the same, right? So the length is 7 times 3.5, which would be 24.5. Cool? Does that make sense? So that's how I would solve for x. And there's one almost exactly like this on your quiz. Yes? No, I don't. Actually, I usually do. Sorry. I think I might have one actually in my office, but not on me right now. Okay. I'll check when we go outside. All right. I also might ask you to solve for this angle, to solve for the measure of angle LMJ. Shh. So this was the answer to this question. I might ask you to solve for the angle LMJ.
Wait, what did you do? Is that 5?
Sorry. Yeah.
Did you do 5? C minus 6.
Guys. Too much talking. Okay. So I might ask you to solve for the angle L, the measure of the angle LMJ. What do I know about these two angles? Are they equal to each other? Are they congruent?
No.
Class? Raise your hand if you think they're congruent.
No.
What are they actually?
Supplementary.
They're supplementary, right? They're consecutive. They're one right after another. So they're supplementary angles in a parallelogram. Does that make sense? Okay. All right. So if they're supplementary, what do their measures add up to? 180. So what do?
You combine like terms and then equals 180.
I do 5z minus 6 plus 2z minus 3 equals 180. Clear? Combine like terms. 5z plus 2z is 7z. Minus 6 minus 3 is minus 9 equals 180. I add 9 to both sides. I get 7z equals 189. I divide by 7. And I get z equals 189 over 7 is 27. Is that pretty clear? Okay, so those are two very good examples. I'm pretty sure those are the exact examples I give you on the Kahoot. Any questions on those? Okay. All right. And the last thing.
And we're doing the lesson?
The last thing, yeah. The last thing that I'm interested in is this. What do I know about the diagonals of a parallelogram? They bisect each other. So I ask you to solve for B. Well, what do I know about 5b and b plus 8? If it's bisected, then those should be equal. Does that make sense? B plus 8, 5b. So this has to equal that. Does that make sense? Because the diagonals bisect each other. So if I want to solve for b, I do b plus 8 equals 5b. I subtract, I subtract b from both sides. I get 8 equals 4b. Divide both sides by 4. I get b equals 2. Now if I wanted to get the length, for instance, from w to y, then I'd plug in. 5 times b is 5 times 2 is 10. I know this has to be 10 as well. 2 plus 8 is 10. So wy, for instance, would be 10 plus 10 is 20. Does that make sense to you guys? You guys get this? Any questions? You guys ready for the Kahoot?
All right.
Cool. Let's do the Kahoot.
Well, I need it. Everyone likes speaking.
That's not true. I like you all equally.
Maybe that's over there. Does anyone have a phone charger?
I swear if anyone says yes and gives it to her, I'm going to be very mad.
Marcus, be quiet.
You be quiet. I asked first.
Okay, guys, Kahoot time. You guys want to go outside? Let's Kahoot.
That's exactly what it says.
All right, there you go. Kahoot time.
Hold on. Wow, you're really doing
Fantastic. Naughty nicknames to be aware. One click on your name and you're out of the game. We got 9 people in this room. One more. This is the last. 5, 4. All right. Zoom. Nice. Speedster.
Clean.
Solve for x. Solve for x. Solve for x. x.
It looks too simple.
It is simple, but I like it that way. Come on, everyone's answer. 119.
Well done.
Those angles were supplementary. The opposite angles are congruent. Consecutive angles are supplementary. Solve for y.
I don't like it. It has some
Oh, bro, it's this.
Alright. They were congruent. Those ones were congruent.
Wait,
I'm so
whoa,
confused.
fourth place.
I just saw this thing.
Okay, hold on. Look. If I draw a parallelogram, okay, opposite angles are congruent if they're opposite one another. So for instance, those two are congruent
I was just thinking too fast.
and the green ones are congruent. You see? They're opposite. Look, you see how they kind of like point arrows at each other? Right?
Yeah.
Or they're connected by diagonals, you can think of it like that. The opposite angles are congruent. The consecutive angles, so each purple and green one are supplementary.
The supplement add up to what?
So if they're next to each other, they add up to 180. If they're opposite each other, they are congruent.
Wait, so
Does
then
that make sense?
169 minus 180.
180 minus 69 was 61 was 119. Yes.
Oh, I just didn't do my math.
So like on the question, it just said 61 on the corner, right?
Yeah.
So like,
That's what 6.
So if this one was 61 degrees, then y, which was up here, is also 61 degrees.
then how come the last question it was?
X was over here.
Oh,
So that one was 119 because 119 plus 61 was 180. You have to check which letter it's asking you to solve for. Because there was X, Y, and Z, and I asked you to solve for different letters. Okay, now this one you're solving for X. We did a question almost exactly like this. Yeah, I think so. It was a little different though. I changed the numbers. Good job, class. It was 3. You set them equal and solve for X. Now solve for Z. Right, Marcus? We could be like, yo, geometry. Here's your best subject in the world. Solve for Z. Come on, guys. We can have a geometry section. Geometry. Solve for Z. Are those two angles congruent or supplementary? Supplementary. They add up to 180.
Can we have like a free password quiz?
Remember, these exact same types of questions are going to be on your quiz, so make sure you're actually trying. Almost exact same, just different numbers. Look. 5 minus 6 plus 2 minus 3 equals supplementary, right? This is like this one and this one, right? So you combine like terms 5 minus 2 equals 7. Minus 6 minus 3 minus 7 equals 180. Add 1 to both sides. You get 7z equals 189. And then you divide by 7. Z go. Good. Last one. Solve for A. Guys, this one's a simple one. You can figure it out. Solve for A. What do you know about these two? There should be what? Equal. So it's 3A minus 7 equals 2A. I subtract 2A from both sides. I subtract 3A from both sides. I get negative 7 equals negative A. Divide by negative 1, I get A equals 7. All right, go ahead, my CCA. Your quiz is on my CCA. Quiz is on my CCA. Go right ahead. Yeah, sure. Quiz is on my CCA.
Oh my gosh, Mike.
Why? What happened?
Mike is hella rich.
What? You trying to take me out to dinner?
I call him Mike.
His nickname is Mike because he looks like Mike from which one?
What happened?
It's called Magic Moment.
Oh, so you tried
Okay.
We already talked about this.
Okay, guys, we have a quiz to do.
What?
Let's do our quiz. And then we have plenty of free time
I
outside
forgot.
in the nice warm sun. You can do it. Use your notes. Use everything that you need. Just don't use your friend.
But that's what I'm
You still have to splash now.
We sang her happy birthday even though she was weird.
No, it's
It said happy birthday, Spirit.
Nowadays. Spirit.
Spirit.
Let's do it and while we're doing this.
This is weird.
What are you doing?
Wait, why are you making all the problems like this, Mr.
Are you getting a pencil?
Yeah.
It's right so far. Please, I just need some help.
You can do it.
All I ever.
What are you guys doing? Sam,
I'm in three.
what? Well, we did it. No,
Oh,
it's a quiz.
right.
Come on now. You're right.
You guys remember when Nerf the beatbox or busted the beat on the table?
Very good times. I will forget you. I'm funny. Mike,
Well,
what do you do?
we can't win them all.
I got 100.
In Miami?
You got 100?
Nice.
Oh my God.
Priscilla, you joking? Hold up. Now I have to get 100.
No, I got 100.
Huh?
Oh. Keep it up, guys.
I'm excited for that test that's gonna happen. You guys are all gonna get hundreds on.
Yeah, boy. Wait, are you gonna? This one isn't right? Or this one is right?
Mm-hmm.
Shouldn't this one be,
Still only got 100.
Ooh, hello.